Hey everyone, it's Bradley Bush again with another algebra video for you. Today we're talking about properties of summation. If this is your first time to the channel, welcome. I'm happy you're here. If you're returning, thanks so much for coming back. If you enjoy it or if this is helpful at all, please give me a like, subscribe to the channel, or leave a comment. We'll talk about 3 properties of summation today, and then we'll give you a bunch of worked examples, at least one of them for each of the properties. Summation notation, this is a quick review because we'll use this later on. Summation notation, if we have a long sum, like this one on the right-hand side of the equal sign here, we have a1 plus a2 plus a3, and each of these terms share something in common, the a, but the iterate is different, the 1, the 2, the 3, and it goes up to n. So if we could simplify that and just say a sub I, which is over here on the left, and let I go from its lower limit 1 to its upper limit n. And the Greek capital sigma there, that means sum. So you're going to add the a sub I to themselves and go from I equals 1 to n. And that's about it. Here's some properties. The first property says that you can factor out a constant. Here's the constant. You can factor out of the constant, and it can come out in front. So say you have a sum, you can factor out that constant, and it ends up out in front of your sum. And then you can sum up all your terms, then multiply the constant in afterwards. This, I think, is kind of intuitive. Because notice, say I had a constant c, and I had a 1 plus that same constant times a 2, and we're going to add that same constant in a 3, and it keeps going up to that constant and a sub n. Notice I have a common term. Each of these terms has a c, the same c. So I can really just pull that out, right? I can factor that out, and I can really say that's c out front, and then I have all of my a sub n's underneath, or be left over. Up to a sub n. That's really all this is saying. There's nothing new, it writes it in a very concise way. So let's see an example. Here I have my constant 5, and I have my a sub n, which is I squared. So I'm summing 5 times a squared from I equals 1 to I equals 3. Our rule says we can pull the 5 out front. So notice the 5 comes out front. And then I can perform my sum and then multiply my 5 by it afterwards. So you can see that I have my 5 out front. I have my sum. I have i's here. I need to change those i's to be, say, 1. This is where I equals 2. This is where I equals 3. And I still have my 5 out front. Let's finish computing this sum. So 1 squared is 1 plus 2 squared is 4. And 3 squared is 9. 1 plus 4 plus 9. What is that? That gives us 14. And then I still have my 5 out front. And I have my 14 from my sum. And 5 times 14 is 70. So you can do it either way. You can keep the constant in and then add them all up. Or you can pull the constant out, add your sum, the a sub i's, and then multiply the constant in later. Either way works. Here's property number 2. If we have 2 terms, a sub I and b sub I, and we're adding them together, and that is the thing that we are summing around. If we sum from I equals 1 to n, we really could just break apart these two terms, the a sub I and the b sub I. That first one kind of looks like a q. Let me change that to look more like an a. A sub I plus b sub I. We can actually split them up into two with the same limits of summation. So from I equals 1 to n on both. But we have all of the a's, we'll sum all those separately and sum all the b's separately. And once we finish our sum with the a's and we finish our sum with the b's, we can add them together at the end, which is what we do. There's the sum for the a's and here's the sum for the b's, and we add them together. But the cool thing is that because of the fact that addition is commutative, meaning we can move things around, 3 plus 4 is the same thing as 4 plus 3. We can move the terms around. That makes this possible. So here's an example. I have my terms, I and I squared. The first one, I, we'll call that a sub I, and b, we'll call that, or sorry, I squared, we'll call that b sub I. So there are my two terms. I can really just split those apart and sum them individually. So that's what I do. I take my I, and I have 3 times, right? I go from I equals 1 to 3. So I have I equals 1, 2, 3, 3 of them. I need to replace I with what it actually is. So we have 1 here, I equals 2 here, and I equals 3 here. Perfect. And the next one is the I squared, the summation of the I squared from I equals 1 to 3. So I have I squared written 3 times here, and I need to 1, looks like I deleted my square. I have a 2 squared and I have a 3 squared. So 1 squared is 1, 2 squared is 4, and 3 squared is 9. Now let's add these separately. So I have 1 plus 2 plus 3, which gives me 6. And I have 1 plus 4 plus 9, which gives me 14. Then I can just add 6 and 14, and I get 20. So the sum of this ends up being 20. This next property is exactly like the last property, but instead of having a plus, we have a negative. That's it. Besides that, it's the exact same property. In fact, if I just change those, you could see those. That was exactly the only difference between the previous property we just got discussed. So we can split these up just like we did before. Again, the difference is we now have a minus in between, and we're subtracting the 6 and the 14 instead of adding the 6 and the 14. So let's quickly go back in and perform the actual sum. We know what happens up to this part. We split the I and the I squared, and we sum them separately. So we have 1 plus 2, and then I equals 3 here. That gives me 1 plus 2 plus 3, which is 6. And this second term, whoops, it's the wrong thing to delete. The second term, we get 1 squared, which is just 1. And we have 2 squared, which is 4, and 3 squared, which is 9. And 1 plus 4 plus 9 is, again, 14. Before we added them, now we're subtracting them. So 6 minus 14 gives us negative 8. So the sum from I equals 1, 2, 3 of I minus I squared gives me negative 8. These are 3 basic properties of summation. Hopefully you enjoyed this. It was helpful. Thanks for watching and have a great day.